Hey, we're back with lesson 15 in module 2. You'll notice that I have a fancy new headset here. Hopefully that's allowing you to hear me a little bit better. I know it's certainly going to help me when I'm in meetings with other teachers and with parents and things like that to hear them really well and hopefully to be really clear. And I'm hoping that we have the added benefit tonight and throughout the rest of our lessons of being able to hear me really well while I'm teaching math to you. We are going to do something that's not new, something you've done before, and that is use the standard algorithm for addition with regrouping one time. And this is what your parents refer to, and I refer to it too, as sort of the way that we learned it, the sort of old-fashioned way, if you will, the traditional model of adding. And it's something that it's really critical that you know. I stress this a lot in class, and I really think that it's important that you develop a really good understanding of how to use this because it is something that you'll use throughout the rest of your life. So let's go ahead here and take a look at a couple of sample problems and see why it works and how it works. And again, this isn't new. We've done this before. It's just a refresher to make sure that you're really grasping those concepts and able to use this in your everyday work. So let's take the problem 23 plus 19. Okay. And while I do that, I'm also going to show you the 23 plus 19, like I was using longs and cubes, like you had manipulatives in class. So I'm going to show you how to do the addition, and I'm also going to show you what this would look like if you had some manipulatives in front of you. So for the 23, I'm going to draw that like 2 longs and 3 cubes. Okay, so that's 2 longs, which is 10 each, 10, 20, and then 1, 2, 3. And we're adding that to 19, which I'll do this in a different color, is 1 long for the 10 and 9 cubes. So 3, 4, 5, 6, 7, 8, 9. Okay. So again, I have my ones column. I'll separate these out for you. My ones place and my tens place. And I'll do that over here as well for you. Ones, tens. You're not going to be expected to set it up this way every time. I'm just doing this to help you understand why this works. And then once we have a good understanding of that, we'll go forward and we'll be able to do these a little bit more quickly. But on this first one, I really want to slow down and show you why things work the way that they do. And the real key thing to understand here is when you go to make your answers down here, you cannot have more than 1 digit in a place value. So in the ones place, you can only have 0 through 9. You cannot put, for example, you can't put a 12 down there. 9 plus 3 is 12. We can't put the entire answer 12 right there. And then if we put, 2 plus 1 is 3, that's incorrect. This answer is not 312. Only 1 digit can go in each of those spots. So one thing can go there, one thing can go there. If you get an answer like 12, you need to regroup or carry and put the 10, the 1, over in the tens column where it belongs. And let's take a look over here on the right and see why that works the way that it does. Let me get a different color here. So I'm going to make, if I can, I'm going to make a group of 10. Right? And so I have 9 and 3, and I know that that adds up to 12. So I'm going to make a 10 by taking these 9 on the bottom and adding 1 to them. I'm going to circle all those. Right? And since that's a group of 10, I have one group of 10. I can move that group of 10 over here and add an extra long. Right? And then what do I have left over? I have 2. So I end up with 1 long and 2 cubes. That's another way to write out this. I had 12 cubes initially. I can write that out as 1 long and 2 cubes. I'm going to erase those so you don't get too confused. The leftover, the things that don't make a group of 10, those go here as a 2. And we've already regrouped and moved our 10 over to where it should be, into the tens column. We have these 10 cubes make one group of 10. So it's over here in the column. We have 1 10 plus 2 more 10s, that equals 3 10s, plus 1 more is a 4th 10. So we end up with 4 10s and 2 1s. Let's go ahead and show how that looks on our initial problem over here on the left. 3 plus 9 is 12. So again, we take the 2 from the ones place and we put it there. And because we have a 10, that has to go to the tens column. And we show that we have, with 12, we have one group of 10 in the number 12. And now we add 10 plus 20 plus 10 is 40. So a 4 goes in the tens place, and we end up with 42. And you notice we have the same answer in both cases. So our picture matches the work we did over here with the standard algorithm. Let's go through another example that same way, and then we'll do a couple without the picture model. The reason I show that to you again is just to give you a good idea of why this works the way that it does. So I don't know, let's pick 50, 57 plus 36. Actually, not 36, 39. Okay. And I'm going to separate this into 2 columns just to make it easy to see, and I'll write it out for you, tens and ones. And then I'll draw that same thing over here on the right, just like I did last time. I have 5 longs showing my 50. And I have 7 cubes, so 1, 2, 3, 4, 5, 6, 7. And I'm adding that to 3 longs and 9 cubes. So the 39 turns into 3 longs, 3 tens, and 9 cubes, 9 ones. And we're going to add these together. These can also split into ones and tens. Whoops, my pen went crazy on me again. Okay, so let's take a look at making groups of 10. Can we do it in our ones column? Yes, we certainly can. We have 9, and if we take one more of these things, that makes a 10. So our 9 from the bottom plus one of those ones from the top number adds up to a 10. That group of 10 then goes over there. Right? We basically cross them off of here, off the ones column. We get rid of them, and we move them over to where they need to be in the tens column. Okay. What do I have left? 1, 2, 3, 4, 5, 6. I have 6 left. 6 ones that didn't make a group of 10. Now I have 5 tens plus 1 10 is 6 tens, plus 3 more tens is 9 tens altogether. So, or another way to look at that is 5 plus 3 is 8, plus 1 more is 9. That's the more traditional way to do it. So we end up with an answer of 96. Let's see if the same thing happens when we use our standard algorithm. 7 plus 9, or 9 plus 7, 9 plus 1 that makes a 10, and then you end up with 6 more. So I'll put my 6 there, in the 16, and I'll put my 1 there for my 10. So notice that 1 in the tens place and the 6 in the ones place here is a 16. That's 1, 10, 6 ones, 16. It's just been split up, right? Leaving the ones in the ones place and the tens in the tens place. And then I have 5 plus 3 is 8, plus 1 more is 9, and I end up with 96. All right, let's do a couple more sample problems. We get into some 3-digit numbers here, and I'm not going to draw out the picture for you every time anymore. I think that you've developed a good understanding of that, I hope by now. If you haven't, you have questions about it, of course, ask. But let's fly through a couple other problems here and get in some good practice. So I might have the number 272 plus 187. Trying to make sure that I only have you regroup once here. Notice that all of these problems I'm only having to regroup one time. We'll save the 2 regroupings for our next lesson, in lesson 16. Just to help guide you, I'm going to separate these into the place values. So on the right, I have my ones. In the middle, I have my tens. And on the left, I have my hundreds. One of the ones place is simple. I have 2 plus 7, or 7 plus 2 is 9. So nothing to do there. That's only, we didn't go into a 2-digit number, so we're all good. Remember, you can only have 1 digit per answer down here. 7 plus 8 becomes a little trickier because that equals 15. 15 obviously is a 2-digit number. So the 5 from, in the ones place can go here, but the 1 from the 15 has to be moved over. So really, since we're working with tens, when I say 15, it's really 150. So the 5 from the 50 can stay here because 50 is a 10, and the 1 from the 100 has to go over to the hundreds column. And then I end up with, I keep drawing lines everywhere. 2 plus 1 is 3, plus 1 more is 4. So no carrying there, no regrouping. So 459 ends up being our answer. Let's do one more. And we will do 688 plus 21. Okay. So 8 plus 1, again, I only have 3 spots down here, right? And this time I'm not going to draw the guides in for you. We know that the right is ones, middle is tens, and left is hundreds. So 8 plus 1 is 9. We're good there. It's only a 1-digit number. 8 plus 2, however, is 10. So what do you do when you get a 10? I can't write 10 in here. That's incorrect, right? So 80 plus 20 is 100, but I can't put a 10 or a full 100 or 10 hundreds in there. So I need to go back and say, put a 0 here and carry the 1 over. So that's saying I have 100 and 0 more 10s based on the 80 plus the 20. Now I have 600 plus 100 is 700. So 7 goes in my 100 spot. 709. And that would be your answer. And again, the key here is when you had the 80 plus 20 equaled 100, right? And so notice that you have in that number 100 and 0 10s. And what we're representing here is 100 and 0 10s. We've already done our work with the 1, so we're not worried about that one so much. But what we are worried about is showing that the 100 is there and that the 0 10s are there. So our 80 plus 20 over here that I pulled out matches what I have on my problem. That's probably overcomplicating it for you. Hopefully you're understanding how to work this system already and use this algorithm. But for some of you that really want to understand exactly how this works, I hope that explanation was helpful. We're going to have tons of opportunity to practice this sort of stuff. Again, it comes up in word problems. It's comes up in everyday life. It's work that you're going to continue to do throughout third grade and beyond. And we're definitely going to get more chance in lesson 16 to practice it with 2 regroupings. Like I always say, ask questions if you have them.